Hey, it's Loop Darks now again with another episode of BackBit Impossible. And in this one, I'm doing audio stuff. I got the audio rollout going on. I try to play it when it's done. I show you how the Digi NMI works, how the audio buffers get filled and when. And, there's a lot of testing and debugging and, trying to get the thing to play and some frustration and fun and wisdom and blah, blah, blah. So, let's watch. Well, it's not very fun to look at, but I believe it's doing the rollout for the Digi Audio now. As you can tell here, sorta, it's loading in 3 kilobytes of Digi data, Mahoney converting it, getting it ready to make the rollout, makes the rollout, saves it. And it's using the quick sort that I did bother to write. Maybe I'll explain how it works maybe right now. Suppose you had all the zeros in a chunk here and all the 255s here. You start in this direction, you find something that's less than 128 and you remember it, and then you go in this direction, you find something that's more than 128 and you remember it, then you switch them. And and then when you get to the midpoint, all the 127s and below are here, 128s and above are here, and then you can pick this gap and sort it. Anyway, yes, so we have a while to go. How many buffers? Well, 931. I'm fudging this number. I'm trying to figure out sort of how much data I need. So actually, it shouldn't take too much longer to finish all this. And after that, I can just get my player going. Or maybe this isn't working at all, at which point I'm completely trashing my only good BBT, which I hope I copied to the computer. I think I did. Yeah. Crap. I forgot. I'm writing to a BBT. No, bad. Well, I'm going to have to stop this. I mean, it might be working, but there'll be chunks of zeros in here, and that's a crackle. So, yep, screw that. We're done. And get that sucker off. Oh well, start up again. Okay, we are now about halfway in the middle of this. Look how slow it is. Do. Come on. 1, 2, 3, 4, 5, 6, 7. Oi! My quick sort is a tortoise sort. It sucks. Well, I guess I could show you, maybe I already have shown you, but all it has to do is sort the Mahoney value and let the, the low byte and high byte follow it along like tag. It should be easy, but I bet you, too bad I didn't do the, what do I call that? The high-speed bucket sort and the quick sort. Each one did a different thing. One did the video, one's doing the audio right now. So they can't really compete on an even platform, but I got a feeling my little high-speed bucket sort is faster than a quick sort, or at least the implementation that I'm using here. But yeah, I guess, because there's a lot more extra moves to do. The high-speed bucket just figures out where it needs to be and puts it there. Starting on the audio. This is an interesting whatever. Of course, it never works first time. Neat. I don't know what it's doing, but it's cool. Oh, it only does it a little bit sometimes. And then it gives up. Yeah. So something's completely effed. Well, that's what debugging is all about. I don't want to do this, but I need to do this. It's going to sound pretty bad if it's silent. Okay, the sound doesn't work at all yet. I'm still debugging that. In fact, I haven't done a thing since I showed you the last time. But I might as well show you, this is my audio player. This is the raw code that is very simple. Once again, I'm reserving the X register for exclusive use during the NMI. The rest of my code better not be using X at all, because I don't save it, I don't restore it during my interrupt, nothing. And I also don't restore or save the Y or A registers. So anyway, we basically get a byte that's already Mahoney converted, play it, increment the low byte, and on the rare case where it wraps, otherwise we just acknowledge the interrupt and leave as fast as you can do it. And then we increment the high byte when we need to. BMI, that's why my audio buffer starts at 6800 and goes to 8000. When it hits 8000, it's here. Most of the time, when it changes a page, it just falls through, acknowledges the interrupt and leaves. But on the very rare, once in, say, I don't know, what is that? 6K? So 6,144 times samples later, it finally hits 8,000, at which point it just resets it back to the beginning. And why? Because I don't need to do anything clever, anything smart, anything thinking-wise, because it happens here. This is what I was so proud of earlier that I didn't show you. After video buffers 0 to 4 are set, we do an audio check. After 5 or 9 get filled, we do an audio check again. And this is all it does. It checks the high byte, and if we're halfway through, well, here, this will set the carry flag. If it's under 7400, it's clear. If it's more, it'll be set, right? At which point we just take a 0 and roll it. So now we're going to get 0 or 1 based on where were we last time. And if it's the same, do nothing. But when this changes, when basically we cross from one side to the other or back again, last audio will change. At which point we save the new copy, queue it up on the BBT, and fill it. And the fill routine is very, very simple as well. It's actually, well, I'll show you you've probably seen this part already. This is the part that does the video. And it's a little more complicated because it's coming in with one of the 4 buffers that it wants to fill, that it's queued up. And we got to look for the end, which is that LDA, make sure that's there, otherwise nothing's going to work. But the fill audio is even easier. Basically, that's it. 37 pages. Start at page 0, execute it. 37 pages later, we're done. And we're not queuing up further audio buffers. We're just doing that and leaving. And as soon as it queues it up, it advances the internal pointer 37 pages for next time. After 0 to 4, video is done. We do an audio check. And if it's needed, we do one of these. And then it does the video again. And if it's needed, it'll do another one. But I started off, of course, by doing 2 of the fill audios, just like I meant to do 2 of the fill videos. So the audio buffer starts full. And of course, you got to reset a few things inside so it knows exactly that it is at the beginning. But that's basically it. So it's very simple. Now the trick is, why isn't it working? Either I've created gibberish data for my rollout, or something simple is screwing up, but I got to find it. While I don't have the bug fixed where the audio plays at all yet, I understand one thing. What I have been doing is letting the video play using a monitor, going in and checking page DF100 to see what it shows there, and also intercepting, like when I'm loading in the audio data, I will intercept it, stop it, look on a monitor and read page DF100. And it's always the beginning of one of these where it's loading, storing, DO21, 22, 23, and it's doing video stuff. But at the end of the video, because I'm just letting it play and just letting it play nicely to the end. At the end, I check the audio buffer, and the audio buffer has stuff in it. And I found out where it was happening, because I'd wipe the audio buffer, play the video completely. The audio buffer has stuff in it. I wipe the audio buffer, stop the video seconds before it's over, check the audio buffer. It's still wiped. Like I'll fill it with EEs or something obvious. The thing is, because of where the audio begins, this is actually filling the audio buffer at the very, very end. It's an interesting bug that's caused by this. Like I said, is if this is there, it's gonna, and I think where I started writing my audio begins with one of those because you need that, right? How do you know what value to start putting down? So when it's looking into the future, it does see the beginning of the audio rollout, but it's a different beast altogether. It does it 64 pages at once, not 37. And so at least that explains why my audio buffer is getting filled at the very end. But it's not doing it right. But that doesn't explain why it isn't playing at all, why it isn't filling at the beginning. That's the next problem. Why isn't it filling? Because I can go in there, like I said, I can stop it when it supposedly just did the initial fills. And there's nothing there. I don't know why. I love mysteries like this because, when you do squash them, wow. But until then, it's like, come on. It's the same type of rush that you might get from a video game. When you're got some puzzle and you're like, oh, if I flip this switch and I move this block here, oh, this will fall here. Oh, yeah. It's kind of like that. And the reward is real. You don't just get experience points. You get true experience, and you need it. So anyway, that's that. I broke in to tell you it's still effed up, and I'm happy that way. My good friend Incrementing Color Thingy says something is wrong. Now I'm examining my rollout code creator. It begins at 5,000. This is the buffer that it writes to the BBT later. So far from 5,000 all the way up to 5A, I'm only up to this value and then this one and then this one. It's like, I don't think it's working right because I don't even know if those are values applicable to the Mahoney 6581 things. I'm going to check them out. Another thing I don't like, because I'm a stickler for elegance, you see how they're not sequentially listed? Because that's a side effect of them being shuffled and then shuffled further and refined, and they're branched in weird ways because of the quick sort. I might do this as my high-speed bucket sort anyway. That way I'm going to get a nice way to compare to see how much faster my routine is than the quick sort. But I got a feeling I might have messed up in the first place. It may not be quick sorting at all in any significant fashion. It might be completely, well, you can see it is introducing like the 17s and 19s. It's introducing the values as it should. And all of a sudden it jumps to here? What? What about every value in between those? Something isn't right. Yeah. Because this might have made its way to the BBT, but just because it executes, it sure ain't useful, is it? Man, that sucks. Nope. Here's another mystery. Why does it do that? Serious? I got a feeling, because I'm starting to get pissed off here, so I'm trying to isolate just the stuff that does the sound. And, well, listen to this. And then it locks up. Doesn't matter. I got a feeling the data is, yeah, it's sorted by zeros and ones and whatever, right? Mahoney numbers, but it's also scrambled. And if that's the case, well, actually, it's not supposed to be sorted. What the hell was I thinking? You don't sort it by Mahoney number. You sort it by Oh. Or do you sort it at all? No, you do sort it by number. But then you also have to put, like, you sort all the zeros, but then you write all the zeros in weird locations and then all the ones. And yeah, okay, so maybe I do have that right. But why isn't it working? Oh man, this is so frustrating. I changed the frequency. I added 768 to it. It sounds like a cheap helicopter from some old game. Yeah, sucks.
You're pretty busy looking this way and that way, kiddo.
Crap. No, it's not. It's just after midnight. This is not the entire cause of the deal. Well, let's look at line 194 here. Okay, I set the frequency to 129, right? But up here, there it is. Load frequency, set it, right? High byte, low byte. No, because that is just, it's taking it as the location. Well, guess what? What's in location 129? A value of 32. So I've been setting my NMI frequency to 32 cycles between, oh, yuck. There. So that fixes some of the problems. And it sort of plays, but it's really, really crackly still. I don't even want to play it for you because I think I've got other things in the works that I haven't saved yet. But wow, that a missing little numbers, hash sign, whatever you want to call it, that was a big problem. And I still haven't found them all. As it is, I know I can get this thing playing from disk with the Mahoney tables in memory, just feeding it the bytes to D418 as fast as I can. It plays it slow, but it's the proper noise. So why isn't this the proper noise? I'm still working on that. All the digging around tonight I've done, I've come to the conclusion that the rollout somehow is corrupted, and I don't know how I did that. But so what I have here, this is the Mahoney table for the 6581 SID. I stuck it at C500 because the code I create to do the job is going to be at C1000 and hopefully not this far. And I can't have it where it normally goes because there's a lot of stuff has to happen there. So anyway, I'm going to get the rollout going again. And yeah, this thing's off. This is for reals. I made a new copy of the BBT, kept the old one, with the flawed color or the flawed audio. And let's hope this new one works. It'll take, 2 or 3 hours or something. It's still the pokey, slow, quote, quick sort. Yeah, right. Yeah, it turns out I did need to relocate the Mahoney table. But anyways, start doing your thing. Come on. Oh, man. Is it even doing anything? Nope. There we go. Okay, this is on. This is whatever. See a red blink, and then we know we're cooking. Okay. Oh, man. And it's like 900 and some of these to go. Yep. It's almost 2 a.m. I don't think I can stay up long enough to deal with this. Maybe I'll go to bed. Maybe I'll play PlayStation. Whatever. So we're left with a little bit of a mystery here. Did I end up going to bed, or did I stay up and play PlayStation?
I don't think we'll ever find out. But anyway, in the next episode, I do believe things go right. And the only indicator I have of that is the episode title, The Sound of Satisfaction. Next time on BackBit Impossible.